Today we're going to do an electrolysis experiment using copper-2 sulfate solution and copper electrodes. Before we start the experiment, we need to understand that this is a manipulation and measurement lab, so you need to pay keen attention to how I'm using the apparatus and how I'll insert these copper electrodes into the electrolyte, of course, which is the material. So the first thing we need to focus on now is this ammeter. We use the ammeter in the lab to measure the amount of electricity or current flowing through a circuit. So we have the negative connection right here, and we have two positive connections. So these two positive connections are linked to the scale that you see here. When you connect it to the 1 ampere connection right here, you're going to have to use the 1 amp scale, which is a top scale. So when you come in the lab, you need to pay keen attention how to use that scale. If you connect it to this 5 amp connection right here, then of course you'll be using the bottom scale. So right here we have our power pack. So it's just a DC supply instead of using a battery. We just purchased this apparatus right here, and you'll see this aspect here. Just plug it into the socket and we use it. So normally when we're doing electrolysis experiments, it's on 9 volts. And of course, to turn it on and off, you switch the power button right here. So in front of me are some connecting wires. Whoops. And you have attached to the connecting wires some crocodile clips for you to easily make the connections that you need. And of course, our electrodes, which are copper rods, and you need to mark them. So right here you can see I'm marking cathode, which is a negative electrode. We have anode right here, which is a positive electrode. So let us now go ahead and make our connections. When we're doing the connections now, there are two things you can do. Number one, these can be screwed up and down, so you can either connect it from the top right here, or you can just simply make the connection right here. And then because we're going to use a 1 ampere scale, I typically prefer to make the connections on the bottom here, to connect it here. To the power pack, which of course everything is dependent on, we're going to see positive and the negative. So if we're leading it from the positive end of the power pack there, then of course we have to connect it to the positive end right there. So we've done those connections. So again, the positive to the positive, and because we have to complete the circuit now, we definitely have to connect this one to the negative end. So the negative electrode is a cathode, because remember, cations go to it. So make that connection and put it in this glass beaker. When you put the electrodes in the beaker, they cannot touch. So once we've done that, then of course we'll just plug in everything, turn on the power, and once you see the needle being deflected on the ammeter, then you know that you've done your connections properly. If there is no electricity flowing through, or suppose you see the needle deflecting before 0, then you know that alright, something is wrong. So when you come in the lab, this is what I expect you to do. If you need to replay the video multiple times so you can get it, then no problem, because we need to be very efficient when you come in the lab. So once we've done this, everything is good. And remember, you have to weigh the electrodes before the experiment and after the experiment. Sometimes what we do after the experiment has finished is that we'll just take the electrodes out and might just gently pass it over a bouncing flame to dry it properly, but not enough to say burn it or anything like that. So we just do that now before we wait, so that we can get rid of all the water so it doesn't increase the mass too much and give you erroneous values to work with. Over there, you'll see an experiment now that was set up before. So I'll put the values on the board and then we can do some calculations regarding what you'll be doing in the lab. So look at what's there. I'll tell the value of the anode and the cathode, the weight of it that is in mass, before we do our calculations. So we're going to pause the video for now. Once that experiment has finished, then we'll resume. We have the experimental data on the board. From the table, you can see that the mass of the anode decreased by 0.1 grams and the mass of the cathode increased by 0.1 grams. The current that flowed through the circuit during the experiment had a value of 0.12 amperes, and we read this from the ammeter. The time that the experiment ran for was 35 minutes. So if you convert 35 minutes to seconds, we'll get 2,100 seconds. The quantity of electricity flowing through the circuit can be calculated using the formula Q is equal to IT. So 0.12 amperes times 2,100 seconds is equal to 252 coulombs. On this side of the board, we can calculate the theoretical mass of copper that should be deposited at the cathode. The cathode reaction is CuSO₄ plus ions will accept electrons to form copper atoms. So this is saying that 1 mole of copper ions should accept 2 moles of electrons to form 1 mole of copper. 1 Faraday has a value of 96,500 coulombs. To deposit 1 mole of copper would require 2 Faradays, which is 2 times 96,500 coulombs, to flow through the circuit. So, to discharge 63.5 grams of copper, which is 1 mole of copper, would require the flow of 193,000 coulombs through the circuit. In our experiment, we had 252 coulombs flowing through the circuit. So if we do simple cross multiplication, which is 252 coulombs times 63.5 grams, divided by 193,000 coulombs, then of course we can do the mathematics and our answer would be 0.083 grams. So in theory, 0.083 grams of copper should be deposited at the cathode. So you must be wondering, why is it that the theoretical mass of copper that should be deposited at the cathode is 0.083 grams, and over there in the table we have 0.1 grams? Well, it's easy to explain. The thing is, the sensitivity of the scale that we're using in the lab is really poor. So if it is that the values need to change, it has to go up by 0.1 grams or decrease by 0.1 grams. So once it was about 0.05 grams, then of course it will register as 0.1 on the scale, which is why you have a difference in values there. So a more sensitive scale now would have shown you, or would have shown you results now that would match the theoretical value. So that's a simple explanation right there, and I hope that you learned a lot from this video. You've been learning science with Mrs. C. Williams Massey. Bye!